Hi, welcome to the Introstat lecture series. This is the final exam review part number 3 here. Okay, so for the first two parts, we covered the problems 1 to number 25. And so in here, we're going to continue our final exam review. So let's go back to our final exams here. All right, so let's start number 26 here. Okay, so for the number 26, it said that John generated a regression line by using 50 data points. John observed that 40 of the residuals from his regression line analysis are negative. What could be the problem if he used this regression line to estimate a response with the given value of the predictors variables here? Okay, so in here, the first things here, we said, because I said the residuals, 40 of the residuals. So we know the residuals is what? Is the y observed minus y predict, right? So let's say all these residuals are negative. So what's that mean? That means in here, so let's take a look. So if this point, for example, those are my observed point. All right. Now I'm finding a regression line, and then this regression line. So for the y predict, that means y minus y predict. Most often it's less than 0. That means this will be my predictor lines, right? Because then all the point in here in this line, we call this yi hat. So as you can see here, like for this point minus here, like for example, like this point here, this is negative, this is the differences, right? So those are the differences for the observed to the predicted residuals. So I know that's a regression line. So if we use this to predict here, to estimate the response, what are we going to do here? Probably we are higher is what? Is higher, right? So most likely we are going to be what? Overestimate, correct? All right, now let's take a look at number 27 here. So we said data on 85 roller coasters is collected on the duration of the ride in seconds. Okay, and the height of the initial drop in feet. The regression analysis give the model duration is 85.91 plus 0.415 drop. Explain what the slope of the line say, how long a roller coaster's ride may last, and the height of the initial drop here. Okay, so from very from in the algebra time, we know the slope. What's that mean? The slope, that means every, so we typically have, we call this y equal to the a plus mx, right? So we said whenever, so this is in the algebra expression. So what is the m means? That means whenever x increase 1 unit. It depends what you are measuring on the axis, right? So like in here, our axis is drop, the initial drop. So that's the feet, right? So that means when x increase 1 unit, and how much y changes here, right? So if m is greater than 0, that means we know y increase what? Y increase m units, correct? And if m is less than 0, so we know y decrease m units here, okay? So right now for here, we said 0.415. That means every units of the x increase, right? So x is my drop. So that means every additional foot of the initial drop. Then what is the y? So in here, the y is durations, right? So we said the y, how much y change, and the 415 is positive. So I said y increase the m units. So what is my m's here? M is 0.415. So let's try to transfer to this roller coaster's point. So what's that mean? That means for every additional foot of the initial drop, the duration of the roller coaster will increase, by 0.15 seconds here, right? Okay, so let's see which one is ones here. We say for every additional foot of the initial drop, the duration of the ride is predicted to by increase 4.1. So this is our answers, right? Because the duration, what is the units here? This is the second. What is the drop here? This is the foot, okay? Let's see what is the other one is not right. They say for every additional minute of duration, the height of the initial drop predict to increase 415. No, that's not, because they have x and y exchange. So let's say for every additional second of the duration, the initial drop is to predict the increase. No. So now here, part C, for every additional foot of the initial drop, the duration of the time is predict. Now, this one sounds very good, but here, right? Let's say predict of time is 0.415 meter. No, that's not right. It's a prediction the duration is increased by the 0.415. So the answer is what? Is this here. Okay, so now number 28, let's say based on the roller coaster model from the previous problem, a new roller coaster advertised an initial drop of 200 feet. How long would its duration last? So that means I know the durations here, right? Is equal to what? Is equal to 85.91. So it's equal to the 85.91 plus 0.415 drop, right? So if they said initial drop is 200, so this will just be the 85.91 plus 0.415 times what? Times 200 here, right? So this will, if you put it into a calculator, this one will give you 168.91. So it's pretty close to the 169. So here will be our answers here. Okay, now next one's here. So number 29. A researcher wants to determine if the nicotine contents of a cigarette is related to tar. A statistician collects the data in milligram from 30 cigarettes and calculated the R-square equal to the 85.4. What is the 0.854 means here? Okay, so here, remember, what is the R-square? R-square, this is what we call, this is a coefficient of determination. Okay, so we typically use in the A plus BX. This is our regression model, right? You calculate R-square. So how do we translate to this model? Is the, the percent. So that means the R-square is the what is the percent of the Y variation contributed by the X, right? So R-square is the percent of the variation in Y was contributed by the variation of X here, right? So this is our official, so this is our official definition about what is the R-square. So what is the coefficient of determination? Is what is the percent of the correlation? What is the percent of the variation in Y was determined by the variation of X? Okay, so now let's take a look at our problems here, right? So for our problems here, right? So we said nicotine contents, right? So statistician want to determine determining the nicotine contents of the cigarette was related to the tar here. Okay, so the nicotine contents is related to the tar. So let's say the tar is X. So 85.4, before we look at the answer. So what's that means here? That means 85.4% of the variation of the nicotine contents was contributed by the tar contents, right? So let's see which one is the most closely related to this former definition. So it's 85.4% of the variation in the nicotine contents was contributed by the tar. So it will be what is this here. Okay, so now let's take a look. What is A? What is wrong with A? A said the nicotine content is 85.4% correlated to the tar. No, if it's correlated, it should be what? Should it be just R, not the R square? Okay, so this is not true. Then for B is here, the predicted nicotine content is equal to some constants plus 85.4. No, that's not what the coefficient of determination means. Okay, number C, it says around 85.4 of the data point have a residue with magnitude less than a constant coefficient. No, that's not what the 85.4 means here. Okay, let's take a look at number 30 here. The number 30, they talk about, they said a regression analysis will apply to the return rate of the sparrowhawk colonies. Regression analysis was used to study the relationship between the return rate is X, all right? So here is a nice name. They tell us return rate is X of the bird as a returned colony in a given year, and the immigration rate, okay, so this is immigration rate is Y of the new adult that's joined the colony per year. So the following regression give the y hat is 31 minus 31.9 minus 0.34. Based on this above the regression analysis, right? If the return rate was decreased by 10%, then the rate of immigration to the colony. Okay, so let's write here. So this is yi hat is equal to 31.9 minus 0.34 x, right? Okay, so be careful, right? So still, let's try to remember our algebra contents here. So this is our slope, right? So the slope right now is negative 0.34. Okay, all right. So now the slope is negative 0.34. But now here they said, okay, so they said, okay, read the problem, right? They say if, all right, so if the return rate was to decrease, okay, so this be careful. So this one's here said that if the return rate is decreased by 10%, then what is the rate of the colony going to change? See here. Okay, we set regressions here, right? So we set the slope is when x increase 1 unit, then y going to increasing or decreasing depends on the negative or positive. But now the x is decreasing, all right? So here, so x is decreasing. The x is decreasing by 10%. Or you can say another word, that means x is what? Increasing by negative 10%. Correct? So if x is increasing by negative 10%, then how much the colony change? So it will be negative negative 34 times negative what? Will be times negative 10, right? So this will be what? 0.3. So it will be positive. here, right? Because this negative is a slope, this negative is, because it's decreasing 10%, you can say it's changed to the increasing by negative 10%. So it's 0.34, negative 0.34 times negative 10, so become positive. So this one's here, it should be increasing by 3.4%. See here. Okay, so be very careful, right? Okay, now number 31, see here. A researcher wants to know if playing video game the night before the final exam will affect a student's grade. So a statistician collect the data and get the R square equal to the 0.543. The scatter plot trend show more time play video game than lower the final grade. What is the correlation coefficients, right? Okay, so I know the R square. So R square is the 0.543. So R square is the square of the R. So in order to find the R, I'm going to take the square roots of the 0.543, right? Because I know the R can be negative or positive. So in here, it says, I know if you play more video game, so this is a video game, and this is a final grade, right? So let's say, if you play more video game, you're going to have a lower grade. So I know R has to be what? It's negatives, right? So when I take the square roots of the 0.543, I have to have a what? It has to be the negative because R square, it's going like when the more is negative trends here. So let's take a look. So what is these numbers here? It will be negative 0.7369. Right, because I know the R, so when you square the R square, so it's a negative 0.7369. When you square it, you still get a 0.543. So when you take the square root, you can get a positive or negative. So now so you need to decide, is this is negative or this is a positive, right? So you here be very careful, right? So we get this one. So here is a negative here, right? So be careful. Let me highlight here, right? So this is a negative here. The reason why is because they tell you, right? So the scatter plot show more video time, lower grade. So you will see your patterns, negative patterns here. Okay, let's take a look at number 32. So it said, which of the following tests will give you a degrees of the freedom? It's not the whole number. This is what we call the two sample t-test. It's not a pool, right? Okay, so let's see which one is. So it's a two sample pool t-test, two sample t-test. It's not a pool. All right, so let's take a look. See here, pair t-test. Pair t-test, the degrees freedom is n-1. One sample t-test is n-1. Two sample pool t-test, that's degrees freedom is n1 plus n2 minus 2, right? So two sample, not a pool. Remember we said that's why we need the technology to help us and to define. All right, okay. Now let's take a look, number 33. All right, so do twins score the same on the IQ test? The following table shows the IQ score for a random sample of twins. We want to conduct an appropriate hypothesis to test if the twins score are the same IQ. So in here, so first things they say is what is what is the non-hypothesis and what is the alternative hypothesis? Because of the twins here, right? Because of the twin, we know the twins here, this is a natural pair, right? Because the twin, they have the same DNA, those things. So it's a natural pair. So we use the pair t-test, right? So we need to use the pair t-test. Okay, so in here, they also said, hey, define the the D as a twin A minus twin B. So we want to see if the twin score are the same. So what do we want to test here? So we want to test the hypothesis here is the E's, right? So first is the differences equal to 0. This is difference not equal to 0. If I say UA equal to UB, UA not equal to UB, these three, right, those are the hypotheses for what? This is the hypothesis for the two sample t-test, right? Because you are compared to population, but I know the twin, is what? Is the, it's a natural pair, so I have to use the pair t-test. So I need to use this D's here, right? So that's why my hypothesis is mu D not equal to 0. Okay, so now let's take a look. How do we input the data here? Okay, let me go ahead get the calculator up here. All right, so we say the mu D, the D is a twin A minus twin B here. Okay, so let's take a look at this one here. Clear here. Okay, so remember the first things we need to input data here. Okay, so let's do a step. So the edit, right? So this is the edit. Okay, so if you have something already here, clear that out. All right, so then you put your cursor here, and you do then you say a clear, then you clear, then you put a cursor here, you say clear, then enter. All right, so the D is a twin A minus twin B. So let's input. So the first data is 84. Okay, 106, 113, 112. 97, 115, 121. Okay, right. So now I'm going to the twin B's here, right? So twin B's here is 77, 104, and 106, and 113, and 102, and 103, okay, and 117. Okay, so since here this is a pair T, we want to do the twin A minus twin B. So I need to define the new arrays. Here's L3. So L3 will be the array L1. So L1 is the second and the 1 minus the second and the 2. So you will get the differences here, right? So it's a 7, 2, 7. Okay, so we got the data input. Okay, now we want to test the statistics here. Okay, so now let's go to the stat. I'm going to do the tests here. All right, and the test statistics here. So in here, we don't have a statistic, we have data. So I need to use the, hold on, so let me see here. Okay, so let's go back. We do a stat, I want to do a test. So here, this is a pair T, so it's equivalent to t-test. So I want to do the data here, all right? So mu0 still is equal to 0. So the list here, so if you don't have the list here, you want to clear that out, and then you say, I'm going to use the list number 3. So you do a second L3 here, then leave the frequencies here. And because our hypothesis is mu D is not equal to 0, right? So you put it in here, then you do a calculate. So I will get my T, so my T-test is 1.739, 1.739788. Okay, 1.739788, and the p-values here is 0.1325 here. Okay, so you can write it down, 0.1325 here. Okay, so let's let's go back to our final exam. So we know, so we just from the calculator, I know my test statistics is 1.7398. Okay, Then the p-value from the calculator, we say it's 0.1325, so it's here. Okay, so now let's say with regarding to the twin score on the IQ test, what is the critical value for the alpha equal to the 0.01? So this one's here, let's take a look, be careful here. Because this is a pair T's, right? We do mu D is not equal to 0. So it's a two tails, right? So this is a two tails. All right, so the critical value is what we want to find in here. So this is the T critical values, right? Okay, because this is a 0.01, so alpha is a 0.01, but you give to two areas. So what is this one here? This area is 0.01 divided by 2. So this is a 0.005. Right? And remember, right? So now in order to find the critical value, now I need to use the inverse T. So that means I need the left tail value. So this golden value, golden area. So what is this golden areas here? So this is 0.995 here. Well, okay, and how many pairs we have? We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 7, 8, 6, 7. Right, so we have 7 pairs. Okay, so let's go to my calculator. So see how do we find the critical values here. Okay, so the critical value, all right, so it's clear here. You do a second bars, then you go to the inverse T. Okay, so what is the area? We just calculate 0.995, right? The degrees freedom, I have 7 pairs, so it's n minus 1. So what is here is 6, right? Let's take a look at what do we have here. So it will be 3.707. Okay, so it's 3.707. Okay, let's remember this. Let's go back to our final exams here. So this is 3.707. So this is my answer. So this one here is 3.707. And this critical value will be the negative 3.707 because they share the equal tails here. Okay, so now let's take a look with regarding to the twin IQ test. What is the conclusion? Okay, the conclusion is based on the here, because my p-value is 0.1325, is way greater than 0.01. So we what here? We fail to what? Reject non-hypothesis. So what is welcome twin? That means the data does not provide significant evidence to support that twin, the test scores are different. All right, so let's see which one is most closely related. So it say data does not provide significant evidence to support the claim that the twin IQ test score are different. Oh, this one looks like exactly what we said. Okay, so let's see what's wrong with B. Let's say data provide significance to support a claim that the twin IQ tests are different. So if you support a claim, so this statement, that means you reject H0. Remember, our p-value is not small, so we don't reject. Okay, let's see. So this is not true. See here, data does not provide significance evidence to support the claim that IQ tests are the same. No, right? So we say we fail to reject, right? So that means you cannot say does not. Okay, so part D is here. Data provides significance to not support. No, we don't know that because we fail to reject. That means the H0 is they are the same. So it's A here. Okay, and now here is a good place to take a break, and we will come back to finish our last part of this final exam review. Okay, have a good day, and I'll talk to you later. Okay, bye-bye.